Hi everyone, this is coming to you from Education for All. We are still on summation of series after doing arithmetic progression or arithmetic sequences. We are given a question that says, prove that the sum of the first 50 natural numbers is 1,275. In other words, they ask you to prove that the sum of the first 50 natural numbers, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus blah 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 up to plus 50. This is equals to 1,275. This is what you are asked to prove. If you're adding 1 plus 2 plus 3, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 3 is 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 7, 28, 28 plus 8. You keep going up to 50, number 50, up to the 50th number, number 50. Then that sum is 1,275. They want you to show it. So prove it. We know it's true, but prove it. How do you prove it? So that is what we are going to do. We already know that the sum of or the series of an arithmetic progression, that sum is given as n over 2. Let me erase this so that we don't get confused. N over 2 into 2a plus n minus 1 d times d, or yes, here I did something in case you are given the last time, so use this formula. That's why I just manipulated here. So all these three are the same. When you are talking about summation of series, sometimes there is a notation we have to represent that one. You must have seen this notation. This is called a sigma notation. I think it's a Greek letter. Sigma notation. It's telling you, you add up things. This symbol means you add up. You add up what is inside, or what is inside this symbol here. If you are given like this, and you are given here x squared, so you are adding up all the x squares, and they will tell you from n equals to 1 to maybe 200. Right? So that is the symbol they normally use for this summation of series. That's sigma symbol. So if that is the case, what we have here, we are adding the first. When we say natural numbers, we already explained that these are the natural numbers, the counting numbers, 1, 2, 3, 4, 5. So which means we are looking at something like this. For n equals 1 to 50, and we have k, where in k represents these ones, 1, 2, 3, 4, 5. So this sigma notation, n equals to 50, that's you are starting to count from 1, 2, 3, 4 up to 50. And the natural number here is k. This is k. So this is the representation of this question. Prove that the sum of the first 50 natural numbers is 1,275. So we still need this formula. We still need this formula. If you're adding the first natural numbers, this is what it looks like. Suppose we're adding the first squares of natural numbers. Then here, if it was squares, then this will be k squared. Suppose you were asked to add the squares, all squares, those natural numbers, all squares. So this k here will be square. Suppose we are asked to find the cube, then all here will be cube. But now, what is inside here, the formula changes when it is squared. The formula will change when it is just natural number. When we start to do sigma notation, is another topic, maybe I will cover that. But for this, now we are doing summation of arithmetic progression and geometric progression. Let us don't move into that yet. So since we are looking at natural numbers, it means we come back to this formula. We come back to this formula here. Because here we are talking about numbers. So, suppose from this formula, since we are talking about natural numbers, it means our first number will be 1, 2, 3. So suppose this is 1. This number here is 1. What would you get? We'll get s equals n all over 2 into, now 2 times 1 is 2. But this I now will say is the first number, a is 1. We're having 1, 2, 3, 4, so a is 1. So we have 2 plus n minus 1 d. And what is d? The difference between consecutive numbers is 1. 1, 2, 3, 4. You know, the difference between consecutive numbers is 1. So this d again will be 1. So multiply by 1. So then, what do we get here? You will get n divided by 2 into 2 plus n minus 1. This is what you get. And so 2 minus 1, you will get 1. Yeah? So you have now n all over 2 into 2 minus 1, you will get 1. So you get 1 plus n. Or you put it the other way around, this will be n all over 2 into n plus 1. Or n squared plus n all over 2. But normally, we leave it like this. N all over 2 into n plus 1. So, this is the formula for the summation of natural numbers. So this formula now, this is equal to n all over 2 into so that is what we are looking at, the sum of the first natural numbers. Or, not to cause confusion, let me still put k here. This is equals to n all over 2 into n plus 1. That is what you have. Now they say prove that the sum is 1275. So now we have when n is 50, because they said the first 50 natural number. When n is 50, so you now have 50 here divided by 2 all over 50 plus 1. So this gives you 50 times 51 all over 2. So 50 times 51 all over 2. So I can say, if I divide, this gives me 25 times 51. Let me use the calculator. 25 times 51 is 1,257. So this gives me 1,275. So it's proven. This is now proven. I've proven that the sum of the first 50 natural numbers is 1,257 by arriving at this formula here. If you just know this formula, you can just use it. You just state it and use it. If you know this formula, the first of the first natural numbers is n into n plus 1 all over 2. There are formulas you will come to memorize when you start to do a lot of problems. N into n plus 2, n plus 1. And if n into n let me see the other formula. What it says? Into n plus 1, n plus 1, 2n plus 1. This is 4k squared. You get this? Yeah? If the first natural numbers are squared, this is the formula. But you will come to use them a lot when you do series, summation of series. So thank you for watching. Bye bye.